name is Niek Bouman. I'm currently affiliated to the TU Eindhoven, where I'm a postdoc. And we are also working on founding a startup called Roseman Labs. I have a background in electrical engineering and then did a PhD in cryptography at a mathematics track. And also was a postdoc in EPFL in Lausanne and worked for a while in a bank in detection of transaction fraud. And now, so I'm again affiliated to the University of Eindhoven, again in cryptography, and I'm doing research on the topic of multi-party computation.
So your background is mainly in research?
Yes, that's true.
And from that perspective, you are starting a project, or you started a project.
So the project is an EU H2020 project that started in 2017, and it's called SODA, Scalable Oblivious Data Analytics. And I've been affiliated to that project as a postdoc researcher.
Okay, can you tell us more about that?
So the SODA project is actually about building applications, data mining and machine learning applications on top of multi-party computation. And then maybe it's good to start off with explaining what multi-party computation means. So multi-party computation is a computational paradigm from cryptography that allows multiple parties who each have their own data set to compute something on that joint data set, where the joint data set is the data set of all the parties combined, in such a way that the parties do not learn anything beyond the result of the computation. So in particular, I cannot peek into your data set and you cannot see mine, but we can see, for example, the result of some computation. Maybe we want to compute an average of the numbers that we both have. Or a bit more advanced, maybe we want to train a linear regression algorithm on our data sets, while only being able to do the predictions, but not see which data is going in there.
And why would I not just share my data with you? Why do we need an extra layer over this?
Well, this technology, multi-party computation, is targeted at applications or scenarios where the data is very sensitive. So, for example, if you think about health data like medical records or financial data or maybe confidential data in enterprises or what have you.
Okay. And what kind of problem are we solving with this?
I think the problem that multi-party computation can solve is that if there is a setting where parties do not want to collaborate because they worry that their data will be at risk, while there is value in this joint data set, then multi-party computation could be kind of an unlocking mechanism to still unlock that value while guaranteeing privacy for the participants.
Can you maybe, to make it a bit more concrete, give an example?
Yeah, sure. I think the first practical example of multi-party computation deployed in the field was in Denmark, and it was used to run an auction, a closed bid auction between sugar beet farmers and a sugar beet processing company. And the farmers had their own sale curve, like I sell maybe 10 kilos of sugar beets for this price, but if you want to buy 1,000 kilos, I can give you a bit of discount. So there's this curve behind that, this relation, price versus quantity. And at the same time, this processing company has a sort of hidden buyer curve that if I can buy more, I want to have a discount. And somewhere there is this optimum between the seller curve and the buyer curve. And multi-party computation was used to compute that optimum.
Okay. But is this a new technique?
Well, the ideas of multi-party computation date back to the 80s, but it has been for a long time been limited to say academic circles or the academic community, and only more recently, I think the theory has gotten rich enough, and also the computers have become more powerful, and computer networks have improved, so that I think in this decade multi-party computation is getting practical. So you see beyond the startup that we are founding, there are several startups now emerging that are going to commercialize this technology.
So you would say we're now ready for this?
Yeah.
And who exactly is looking forward to this? Who benefits from this?
I think anywhere where there are several parties that sit on privacy sensitive or commercial or confidential data, where there is a benefit to computing something of this joint data set. And one example that we think is interesting, also for our startup, is the banking sector, where nowadays there is a big problem with money laundering. So there are people who launder money via European banks, and for example, quite recently a major Dutch bank has been fined for over 700 million euros. And we think that if banks would collaborate by sharing in a privacy-preserving way the transaction data, then those banks could do a better job at detecting this money laundering fraud.
So the key would actually be, for this to work, is to have a shared vision or a shared goal. Why we do this? Why we use this approach? Yeah.
So there should be first some kind of benefit, and then multi-party computation can be a technology that can help achieving this goal, while giving very strong privacy guarantees for those participants in this joint project.
And what would happen if we start with a shared goal, for example, money laundering or healthcare, solving healthcare issues, and along the way we do not agree with each other anymore on the shared vision, the shared goal?
Then you could always retract as a party, because maybe I haven't said that so clearly before, but if we take a example where hospitals want to compute statistics over their medical records, or maybe more realistically, there is a third party, say the Census Bureau, who wants to compute statistics over medical records that are stored at various hospitals. Then how this would work is that each hospital runs its own server and kind of participates in the computation of these statistics. So if at some point you would not agree anymore to the computation of these statistics, you can literally pull the plug of your server, and then your data will not appear anymore or contribute anymore to this joint computation.
And so this is maybe a bit a detailed question, but what happens then, because you provided the data already?
That's a more technical discussion, but there are several models. There's so-called the honest majority model, and for that model, it is indeed true that you have to contribute your data, but not in the clear, but in some kind of encrypted fashion. But then, as long as there is a majority of the participants, they can then perform computations on that hidden data set. And if you are not among that majority, then your data would be at stake in that way. If there's an honest majority that is colluding and then doing or performing computations on that data that you wouldn't agree with. But there can also be a different flavor which is called dishonest majority, and then you will remain in control of your data. So you can always retract, so to speak, and then other parties cannot perform any computation on your data anymore. Now, the difference between dishonest majority and honest majority, or you could ask, why would we not always then use this dishonest majority flavor, because it sounds better, but the disadvantage is that the performance is lower. So if you have to crunch a big data set, you might not meet your performance goals in this dishonest majority model, and you would have to resort to a honest majority model. But there are, I think, also alternative ways to enforce this honest majority in legal terms.
Okay, so it sounds a bit like a democratic model, actually, to me.
Yeah, there has to be a consensus about what is going to be computed.
Yeah.
And then, the only parts about which there is a consensus will be computed. Yeah.
And who decides what will be computed?
That's a good question. That's, I would say, the parties that run those servers, because they are in control about or over their own server, so they can decide also to shut down the server. Mm-hmm. So they are also the natural entities that should decide about what gets computed or what not.
But those are the participants, and they can decide to take a step back and not participate anymore. But who decides what kind of calculations are made in the first place? I think that there is a governance aspect to this, and that governing board can be the same parties who also apply the computations or perform the computations, but there can also be, say, third parties, say notary-like entities that contribute to this governance board. But I would say that is a deployment discussion, which is not so much about the technology. Or I'm a technology person, mm-hmm. or mm-hmm.
a technology-related researcher. So what you are asking is very relevant questions, but I'm maybe not the person who can best comment on those questions.
We will learn about that later.
Yeah.
All right, thank you. And what kind of? It sounds quite promising. What kind of challenges do you expect? Do you see?
Well, one challenge is that, especially if you talk about machine learning applications, that people are nowadays used to the performance that you can get on a cloud or with a cluster of GPU cards, and in multi-party computation, for almost any computation, you will have to communicate with your peers or with the other participants. And this communication takes place over a network. So we always tell people about, or we give them some kind of disclaimer that the computer that you should envision is more like a 386 than this.
Can you maybe describe a 386 for
yeah,
our
well,
listeners
like
who are a bit younger?
a computer with the power that we used to have in the 90s, so to speak. And still we can put hundreds of these computers in parallel to speed up things. But if you have a very sequential type of operation, then you feel kind of the performance drawback of that 386 computer. Yeah. So I think managing expectations about the performance is an important aspect nowadays. But that doesn't mean that there are not many applications for which MPC is already practical, because sometimes you can also do some heavy pre-computations locally, so that you kind of prepare a small data set on which you will do the actual multi-party computation. And in your own server you have already compressed, or you have processed a lot of data and made it smaller into this core set that you want to compute on with the other parties. And that sometimes that is also called federated learning, that you have a local step that acts as a funnel, so you end up with a lot less data that you will process jointly.
Okay, but for me as a non-technical person, for me it sounds like this is quite an easy challenge. It's about speed, which is for me a technological issue, which I would say quite easy to solve maybe in the next coming years.
You could say that the speed will automatically become better if better networks and better computers come about, and that's true. And maybe it's also because I'm wearing this technology hat that I first think about the technological problems, but also the problem of how are you going to set up such a collaboration in practice? How are you going to get kind of the home free card from a privacy officer, because a privacy officer has to give an opinion about whether this technology in that particular deployment can make, for example, from personal data, it can turn it into non-personal data in the GDPR sense. Those questions are of course also challenges.
And what would you say would be like more the risks in this? Like a risk of this approach of sharing, not sharing your data, but only be part of a network and only get the results back that are based on the data that everyone provides.
It's a good question. I don't really see risks because I view it as kind of a superior way in a privacy preserving or with respect to privacy. I think it's a better way to process data. So in that sense, I would say it would bring down the risks rather than creating new risks.
Okay. Okay. And you were talking about your startup. You haven't talked about that so far. What kind of startup is it, and what are you aiming for?
So the startup is called Roseman Labs, and the reason that we are starting it is, as I said in the beginning, we feel that now this multi-party computation technology is becoming ripe for the market. Is becoming mature enough for commercialization. The goal is to solve or find business cases where we can unlock this value, which does not get unlocked today because people don't want to share the data. I think the example of money laundering is one case where everyone would benefit of a better money laundering detection.
Without the need of sharing your data with others.
Because I don't want my financial data to be on the street or fall in the hands of criminals, for example. And what there I see maybe one risk is that nowadays, in the Netherlands at least, there are efforts of founding an entity that is going to be responsible for detecting money laundering. And all the banks will have to copy their data to that entity, which means that it becomes kind of a honeypot for attackers. If somebody succeeds to gain access to this trusted party, then he has not the data of one bank, but he has the data of all the banks. And there I think that multi-party computation could decrease that risk by making sure that the data is not in one place in a clear text fashion.
But still, the data, to make the calculations on the data, it needs to be out there. It needs to be somewhere. Is that hackable?
Well, you decrease the risk because you go to a certain a threshold situation. So the attacker does not yet get the data when he breaks into one computer, but now he has to break into at least 3 computers or maybe 5 computers, or that's actually a parameter that you can set. So you will make it much harder for attackers to steal data. So it's primarily also a data breach, a prevention technique. Yeah.
Are there specific sectors or areas in which you would like to focus more, where this approach is more valuable than others?
So I've just mentioned the financial sector. I think another interesting sector is the energy sector, where, for example, energy companies have installed the so-called smart meter in your house, and your energy usage is very sensitive data. Because if I'm an attacker or a thief, and if I could see your energy data, then I could deduce from that you are now not at home, because I don't see the lamps going on and off. So that's very sensitive data, but on the other hand, this data can be very valuable, for example, for grid operators. And nowadays, the usage of the grid is changing because of decentral generation. People put solar panels on the roof, but also people now buy electric cars and want to charge that car in their own street. And this grid that has been lying there for 50 years or maybe 100 years was never designed for this new use case. So grid operators want to have an insight into the situation of the grid. And maybe we can leverage the smart meters for that purpose, but now that is not allowed because of privacy reasons. Yeah.
So if the technology would be in place, what else would we need? Because from a technological perspective, what the only challenge might be is the speed. How do we apply this on a large scale? What do we need to make this a successful approach?
I guess we want to start with proof of concepts, and because also, we are one of the first who want to try this, applying MPC to, for example, the energy sector. So I'm also not sure what kind of problems there will be, but let's do a proof of concept and let's find out whether it is indeed fitting that use case well enough to deploy it at large scale. So we have to basically learn and start learning by means of doing proof of concepts. And maybe another interesting sector is the telecom sector, because there are telecom operators who, for example, know where you are at this moment. They can see to which tower your phone is connected. So they sit on a big amount of location data. And local governments, for example, for city planning, they are interested in buying that data. And again, with multi-party computation, you could run multi-party computation between several handsets, and then have a more granular view of location while preserving the privacy of those individual handset owners. So that's another example, I think, where we might be able to unlock value that is there but cannot be unlocked now because of privacy concerns. And
who would pay for that?
In that case, I guess the buyer of that location data. But it's quite a huge market. It's already, I think that telecom operators, they make significant money, not just by getting money from you as a subscription payment, but also from users of the location data.
But in this specific case, the government wants to have the data, right? You gave an example.
Yeah, that's just one example of a client, like local governments.
Would pay.
Yeah, then that would be the data client, but there can be other companies who are interested in location data. Also, for example, producers of maps for cars. They are maybe interested in updating maps or seeing which route is at that moment the fastest route from A to B. That could be another example of a client of such location data.
And if I may go back to your example of health, imagine we're sharing health data in a network, and how are the nodes in the network rewarded for sharing their data, or providing, it's not sharing, providing their data? Because they are, in one case, they're rewarded with the insights that they are looking for and maybe solving the shared goal. But maybe the results are not shared with them, for example.
Yeah, I think that the reward scheme is kind of orthogonal to the technology. So you can come up with a reward scheme that works for you, and then use multi-party computation in a way that is compatible with that reward scheme. But in essence, multi-party computation doesn't say anything about that, or so it's kind of a different concern. It's a separate concern.
Yeah, I'm just curious that if a specific hospital wants to have this results, these insights, and pays for that, then how are the ones providing that data rewarded? Where does the money go?
Yeah, I think that really depends on that particular business case. So multi-party computation gives you the technical means to compute this statistic while providing or guaranteeing privacy with very strong privacy properties. And then, who has to pay for that? That's kind of for the participants to decide.
So the business model behind it's context dependent, participant dependent.
Yeah, and it's a good question. I mean, of course, you will have to go through that question if you are doing an actual case, but that's kind of independent of the technology.
The technology.
Yeah.
Okay.
Yeah.
Okay. And where do you see this going? This approach, the next, let's say, 5 years?
Well, I hope it's going into a good direction for our startup. The question is, are we at the right time? And in the sense that is the performance that MPC can give us today, is that sufficient for the relevant use cases?
Yeah.
And I'm convinced that is the case, but it's still, we have to prove that in the field, that is true, because so far that's my intuition. I think that the technology multi-party computation and also the technology homomorphic encryption that we didn't discuss, but it's a related technology in the sense that it's also coming from the academic field of cryptography, but this is more in a client-server model, that you have a computational job and you want to execute that job in the cloud, but you do not trust the cloud. So you do not want that the cloud sees your data, but still you don't have the means yourself to process that data. And for that, homomorphic encryption is a useful technology. And both of these technologies, and also the technologies that are related to blockchain with provable guarantees, I think they are all getting more and more attention, and I think that they will be applied more and more over the coming years.
So the first step would be finding use cases, see how it works in practice. Besides the technical aspects, what else is, what other challenges needs to be addressed in this approach? So that's again, I think the reason for the startup, that we believe that now is the time to deploy these technologies in the field. Would you need help from a European perspective in standardization, legal terms?
That's a good question. I think we try to bootstrap with local partners, also to keep the lines of communication short. So also in terms of getting an opinion from the privacy officer, I think we would start at a national basis. And yeah, to scale, I think it could also always be interesting to do European projects, and also to maybe partner up with your organization. Also to make people aware of this technology, because so far I think that people think in a black and white sense about data sharing. Like either you keep the data for yourself or you share it in the open. But this technology is one example where you can be kind of in the gray zone, where you do not share it in the open, but still can compute useful stuff based on it.
Yeah, interesting approach. Is there anything else you would like to address? A main message you want to give?
Yeah, I think that that we have to be, in some sense, at the one hand, technological advance or new products, new technology has brought us a lot, but we always have to remain critical and careful that we keep protecting our privacy, because I think one problem that we see now in the world is that the balance between the individual and big corporations is switching towards the benefit of the big corporations. There's also, during this conference, somebody mentioned the winner takes all. Yeah, we all know the examples of the companies who are the winners in the digital world. And in the end, it's not good if there's one company or one entity that is becoming very powerful. So in that sense, I also view multi-party computation, along with other privacy-preserving techniques, as in some sense a good thing from that perspective. That that you try to protect privacy.